Hello, today we are going to talk about simultaneous equation model. So now basically when we talk about simultaneous equation model, it has a very close relation with identification problem also. But for current lecture, we will only talk about the simultaneous equation model. Now, first of all, we need to identify such kind of system of equations where we need simultaneous equation model, right, where we can see where we can say that yes, this is a simultaneous equation model. So I have taken the two system of equations given in the slide, right, and we'll talk about them. So in the first, this is your first system of equation, or you can consider them as this is your first equation, this is your second equation, and for the second model you can consider it to be third equation, this is as your fourth equation. Now according to the first equation, what you can predict about just by seeing that first equation, you can say that okay, this C, which is your consumption here, is your dependent variable, and income here is your independent variable, and definitely mu is your disturbance term or stochastic term, you can say, and autonomous consumption is something which is constant or intercept term, you can say. And for the second equation, you can see that this is your dependent variable, and income and wealth both are your independent variable, and other things are same as the first equation, right? So can we use OLS estimator? Can we use OLS method? Well, yes, we can use OLS method. That means in the first equation, individually we can use. That means just by using first equation and by using OLS method, we can definitely find out the required parameters or the required statistics for the first equation, right? And simultaneously, for the second equation, which is the including wealth, we can also apply our OLS method, right? We can apply OLS method, right? And you can definitely find out your consumption, then your C capital, then del capital, and these are the things that we find as an estimators, right? So we can use OLS method in this system of equations. And these two equations are not connected with each other in any sense, right? So this first equation is different and second equation is different, right? So we do not need, or there's no dependency of any of the equation written in the first set of equations, right? This is your first set of equations. But when I'll talk about the second set of equations, here what is the difference between first set of equation and second set of equation is that, see, in the third equation, which is this third equation, so here you can see that the consumption at t time. So first very main difference between the set of equations that here no t as a subscript, no subscript has written, but in the second method, T has been written, though this is not a important thing in a simultaneous equation model, but you need to be very much aware about the subscripts also, right? So first and foremost thing is about the time series data, right? Which is the second equation, second set of equations, right? Second important thing is that about the consumption. See, consumption is a function of YT, that is your income, right? So you can say that consumption is your dependent variable and here income is your independent variable. But now in the fourth equation, what you can see is YT is now your dependent variable and CT is your independent variable. Don't you see this is something very weird happening in this set of equation? Because in the third equation, the model is saying that consumption is a function of yt, but at the same time another equation is saying that yt is a function of ct, right? So there is this difference. What is happening? There is a role change role change happening, right? When consumption was once a dependent variable, now in the another set of equation or another equation, it is now acting as a independent variable. right? So this is what this is happening, something very weird. So this is the part that we need to study through the SEM, that is your simultaneous equation model. We don't study this set of equations for the SEM, right? And second important thing is that you cannot use OLS method. We'll talk about that in the later classes, or later part of this lecture. Now we'll talk about the endogenous and exogenous variables in both sets of equation. In first set of equation, as simple as that, this is your first equation, this is your second equation. In the first set of equation, you can see that since this is your independent variable, right? This is your independent variable and this is your dependent variable, which means, and since they both of the equations are not interrelated, or they are not dependent by any chance or by any means, they are not dependent. So what I can say is, which one is exogenous? This is exogenous. Which one is exogenous? Y is exogenous. And in the this is your consumption. And for the second equation, which one is your exogenous? Now exogenous is income and wealth, and endogenous is which one? Endogenous is which one? Is your consumption. Fine. Now what about this? Now, since from the previous slide we already talked about it, that consumption is a function of yt in the third equation, while fourth equation says that yt is a function of consumption. So how can you now predict or differentiate between which one of them is exogenous and which one of them is endogenous, right? So what you can see is that had it been something like this, if yt increases